Hello and welcome. In this video, we're going to look at a separate way of using GeoGebra and the probability distribution function to solve binomial probabilities. We're going to look at the same three examples that we looked at in the previous video. If you remember from the previous video, we looked at the binomial distribution in the GeoGebra main screen. As we start typing in binomial, we get this binomial dist, which is the distribution, and the previous video went into detail about how to use this using the curly brackets and whether or not we're doing cumulative. What I want to show in this video is how we can switch to a different calculator mode and use a different function. In the hamburger in the top left of your GeoGebra, if you downloaded the calculator suite, you can click on Switch Calculator and choose the probability calculator. From here, as I have previously scrolled up and hid the graph because we don't need the graph, we would select the distribution and change it to binomial. We could either choose cumulative, which we'll see in a little bit, or we could use the intervals here. So I'm going to zoom in on example 5.16. This is the same example as we did in the previous video. It says an online retailer observes that on average 15% of visitors to their website make a purchase. If they have 1,000 visitors in a day, what is the probability that fewer than, less than 100 visitors make a purchase? So our n value is 1,000. So we have 1,000 visitors. Our p-value is 0.15. That's the probability that any given visitor will make a purchase. And our x value, or in the previous video I think we said r as well, we want less than, or not equal to, strictly less than 100. Or if we want to, we could also say less than or equal to 99. Because it's fewer than 100. So in the probability distribution on GeoGebra, I'm going to select the less than interval. We're going to change this parameter to 1,000. Go back to numbers. 1,000. Our p-value we're going to make 0.15. And our maximum value we're going to make 99. We want it to be less than or equal to 99. I don't remember what the answer is here, but it might be that small. Let me just double check. Yes, okay. In our previous video, it was 0.00012603. So because there is such a small value here, it's going to approximate this to 0. So the notation that we could use here is the probability that x is less than or equal to 99 is 0. This is the cumulative function. It would be up to and including all of those values. For example 5.17, it says a software company estimates that 20% of its customers will renew their subscription. If they have 50 customers, what is the probability that at least 10 will renew? So in the previous video, it was a little tricky to try and solve this one because we had to figure out what is at least 10, what does that mean, and we might have to do some weird things because it's greater than. For those that are using the TI calculator, it's a little bit complicated as well. But for us here, it'll be actually pretty straightforward. If our sample size is 50, because we have 50 customers, and the probability of success, meaning that someone renews their subscription, is 20%, then p is 0.2. Our x value, or our r value, is at least 10. At least 10 means that it has to be 10 or more. So x is greater than or equal to 10. So in GeoGebra, we're going to select the greater than symbol. Oh, we have to change everything else. Sorry, forgot to do that. So our n value would be 50 now. Our p value is 0.20. and our our minimum value would be 10. So greater than 10 would be 0.5563. So the probability that x is greater than or equal to 10 is 0.5563. And now for example 5.18, it says a light bulb manufacturer claims that their bulbs have a defect rate of 5%. If a box contains 20 bulbs, what is the probability that exactly 2 bulbs are defective? Well, we need to figure this out based off of the same thing we've talked about in the past. N is 20. The probability that a light bulb, that any randomly selected light bulb in the box is defective is 5%, so 0.05. And the box contains 20 bulbs. What is the probability that exactly 2 are defective? Exactly 2. So we want to know what is the probability that x is equal to 2. So in GeoGebra, we just have to change our parameters. I'm going to change this to a between question, and you'll see here we now have a lower bound and an upper bound, and I'll show you what we're going to do with that. Let me just put in the rest of our parameters. So we have a sample size of 20. We have a defect rate of 5%, which would be 0.05. And now we want exactly 2. So our lower bound would be 2, and our upper bound would be 2. Because we want it to be exactly 2. So 2 is less than or equal to x, which is less than or equal to 2, means that we're just finding the probability of exactly 2. So the probability that x is equal to 2 is 0.1887. So in GeoGebra, there are 2 different ways of calculating binomial probabilities. I hope that you enjoyed watching this. Thank you.